guys, this video we're going to do 32 and 33, so let's do it. It says, prove that the slope criteria for parallel and perpendicular and use them to solve for equations. Okay, so here's our equation, and we have to put it in slope point formula. So if I subtract 3x on both sides, I get negative 3x plus 2. Now I know the slope. The slope's the number in front of the x, and b is where it crosses the y-axis. So now that it looks like this, and you don't have to graph this, but this should help you understand why. So b is where it crosses the axis, and the slope is negative 3. So I'm going to go down 3 over 1, right? Down 3 over 1, that's my slope. So here's this line that they want me to go through this point. So this point is at 6, 8. And they want it to be perpendicular. So it appears like it would be somewhere here. So right off the bat, I'm pretty sure it's going to be D because it's got to be perpendicular. But how would you do this without having to graph? So again, we have our equation, right? And we want this point to go through there. So we can plug this 6 in where we see the x and an 8 where we see the y. And this just goes all the way back to algebra. But then that didn't work, right? So notice by plugging it in, this point is not on this black line. So I can't do that. And that would be following the algebra way. So what way do I need to do it? Well, if this is my line, I know that if my slope is negative 3, then my perpendicular slope would be the opposite reciprocal. So I need a point, and I have the point, and I need a slope, and I have that slope. So on my formula sheet that they've given us, where is that? I haven't gone back to that. On our formula sheet, they give this to us. It's called the point slope formula. So you can use that here. So it's y minus the y value, slope, x minus the x value. We have our perpendicular slope. They told us to make sure it's perpendicular. So we're going to plug in our perpendicular slope. And then they said they have this point for us. There's the x value, and there's the y value. So y minus the y value, 8. And then the slope, x minus the x value, 6. So what do we got here? I'm going to distribute this. So I get y minus 8 equals 1/3 x. We're definitely eliminating these. We definitely know we need our slope of that, right? And then 1/3 minus 6 over 3, we get 2. But notice they're asking for us to get y by itself on one side. So if I add that to both sides, I get 6. And that's what I got from graphing. All right, question number 2. Which equation represents a line that's parallel? So parallel means same slope. So if this slope is 2, if this slope's 2, then the parallel slope is also 2. So we don't really have to graph this. We just need to find which one has a slope of 2. Here we notice the slope is negative 2. Here we got to do a little algebra. So 2x plus y equals 7. Subtracting 2x on both sides, it looks like we get the slope is negative 2 for this one as well. Here, we're going to get this in y-intercept form. So we'll add 2x on both sides. We get y is equal to 2x plus 2. And I think we found our answer. This would be parallel because it has a slope of 2, and parallel means same slope. Let's just double check the last one. if we rewrite this and we add y to both sides, notice we get y is equal to negative 2x minus 9. This slope would also be negative 2. So C is the only one who has a slope of 2, which matches our slope of 2. Question 3, select all the equations that represent a line that's perpendicular. So that means whatever the slope is, well, it looks like the slope is 2, then the perpendicular slope would be negative 1/2, opposite reciprocals. So this is going to be a no because the slope is 1/2. This is going to be a yes because the slope is negative 1/2. We like that, right? Here we're going to have to do some algebra. So if we subtract x on both sides and divide by 2, I do get a slope of 1/2. So I'm going to say yes. Reworking this. Adding x to both sides, you get 2y equals plus x minus 3. So this is looking like it's not going to work because I have a slope of a positive 1/2. And I need a slope of negative 1/2 to be perpendicular because I have to have opposite reciprocals. Okay, last one. If I rework this, add 2y on both sides. I get 2y. Subtract 9. Divide by 2, divide by 2, divide by 2. Nice. Okay, so I do end up getting a slope of negative 1/2. So that last one's going to be a yes as well. Okay, question number 4. It says, what must be true to prove that they're perpendicular? Okay, so we learned that if the slope of, whatever the slope of Q is, if the slope of N is the opposite reciprocal, then they're going to be perpendicular. So if the slope is the reciprocal, no, I need both opposite and reciprocal. If the slope is the negative reciprocal, that's going to be yes. So let's play that out. If the slope, let's say, was a positive number, let's say 3/4, and the slope of the other one is the negative reciprocal, notice that would work. So you might be thinking, well, would that work though if I already had a negative? Let's say my slope was negative 3/2. And if I do the negative reciprocal, negative reciprocal, this would be a negative times a negative is a positive. So that would work. What does this mean multiplied by 1? Well, notice if we multiply this number times positive 2/3, you end up getting negative 1. But we don't want to multiply 3/4 by negative 1. That's what it seems like they're doing there. Okay. Last question on this sheet. It says, which statement is true about the two lines and their equations? Okay, so I could graph these on Desmos, but it's like you can't use that on a test. So you're going to have to use some algebra here. Here, I could play with this question, this part, right? Because it's almost by itself on one side. If I add 2x on both sides, I know what y is. And now I can plug that in. I could also see the slope is 2 and the intercept is negative 8. So if I play around with this one as well, 3x minus 5y equals negative 3. I'm going to add 5y to both sides and add 3 to both sides, so 3x plus 3. If I divide by 5 on every term, I end up getting 3/5 x. So my slope is 3/5 x. So that's not my opposite, not my reciprocal. I don't really have, they're not perpendicular. They're not the same slope. I don't even know what cosine means, but it says they intersect. So that's what I think it's this one, but let's figure it out. We know they're not perpendicular, but how do I figure out if they intersect? Well, that's what I was about to do here. I'm going to plug this in for y and see if I get a number. So 3x minus 5 times the quantity 2x minus 8. Does this equal -3? If it does, then they do meet. Okay, so 3x minus 10x plus 40. End up getting -7x plus 40 minus 3. What else do I want to do here? Usually I would try to add until I get it x is negative. So 40 equals -3 plus 7x plus 3 plus 3. So I get 43 is equal to 7x. So this, I do get a value. X is 43 over 7. And if I plug that back in, I'm definitely going to get a number. So they definitely intersect. They're just not perpendicular. All right, questions for page 33. It says, find a point directly on that segment. Okay, so I really like this one. I think each student can probably get at least 1, if not 2 on this page, depending on the question. So let's first go to question number 4. That's probably the easiest one. It says, what are the coordinates of point 4, 4/5 of the way there? So if you can chop this into 5 equal pieces, I call those bunny hops. Okay, so you need 5 equal bunny hops. Using my invisible right triangle, notice that the x is cut already into 5 equal pieces and the y is cut already into 5 equal pieces. So you can kind of just float over and find the spots to cut that line, if that's helpful. Okay, so yeah, using my pen, I noticed that 5 is cut in the y-axis, cut in 5 equal pieces, so I can find these spots. And then I want to say, I want to go this number 4. I want to go 4 bunny hops, 1, 2, 3, 4, with 1 left to go. So sometimes they use this notation, other times they use this notation, 4 to 1. It's exactly the same location, this location right there. So now let's find our coordinates. This is 0, 0. I had to go over 2, up 2. So there's my coordinate. Wait. That's not my coordinate. I'm trying to get to this coordinate. So over 4, up 4, that's my coordinate right here. Okay. Now, there was a couple curveballs with this. Notice each box in my diagram is 2 by 2, not 1 by 1. So be careful with that. You'll need to count by 2s. All right, let's check out question number 2. What would be the point of the coordinate that's 1/3 of the way there? So I'm going to split it into thirds, and I'm going to look for this coordinate. And if this, where is this origin? They're making this a little bit hard. Looks like this is the origin here. They put the O here. So that would be the coordinate 2, 0. So they're asking, what is the value of P? It would be 2. What is the value of Q? It would be 0. Okay, so again, how do we cut this thing up? Well, if you draw the invisible right triangle, notice that our y-axis is already cut into equal thirds. So we just kind of float over and find that spot, float over and find that spot. So we want to go 1/3 of the way there. So 1 bunny hop with 2 left to go would be 1/3 of the way there. 1/3 of the way there would, you could also show like this. And that's 3 bunny hops. Okay? So let's look at question number 1. They asked us to graph the coordinates -5, -4. So if that were my axis, -5, -4. and then 5, 1. All right, so here's my line. And I want to do the same thing, but now they want it in a ratio 3 to 2. So that means 5 bunny hops, right? So let's investigate. This is already cut into 5 bunny hops, so I can float over and find those spots. Make sense? I also know this is in tens, so that's easy to cut into 5s too. 2, 4, 6, 8, 10. So those line up vertically as well. Okay, so I want to go 3 equal bunny hops with 2 left to go and identify that location. So it looks like that location is positive 1, negative 1. Remember here, we saw that we can show the notation like this, or we can show that that's 3/5 of the way there. 2 ways to kind of list that notation. Question number 3, looking at coordinates -5, positive 3. So I'm just going to make an axis here. Looking at the coordinate -5, positive 3, and then looking at the coordinate 1, 6. We see that this, I'm just going to call it point P. This isn't my journey. It's just my pit stop. So this is a slightly different type of question. They're saying go on a journey from A to P, and in fact, go all the way to B. But point P was 3/4 of the way there. So 3/4 of the way there means 4 bunny hops. It means you go 3 with 1 left to go. So it means you go 3 equal bunny hops with 1 left to go. Right? 1, 2, 3. So see, that's how I figured out how to get to B. If you if you struggled to do that, notice I went over 2, up 1, over 2, up 1, over 2, up 1. So just 1 more over 2, up 1. You also might think you drew what you had here. Notice that the y-axis cut it in thirds already, so they already went the 3 equal units, and they have 1 left to go. So what is my coordinate? It looks like I went over 3, up 1, 2, 3, 4, 5, 6, 7. So my coordinate for B is over 3, up 7. Cool. One more left on this video. So it says a city map makes the coordinate. The post office is at 5:35, the library is at 15:10, and the fire station's at 9:25. Okay, so I have all really big numbers, but most of them are in 5s. So, and they're all positive. So I just need my quadrant 1. Looking at our first coordinate, it says 5 and 35. So 5, 10, 15, 20, 25, 30, 35. Okay, so this is point P at the coordinate 5, 35. L is at 15, 10. That's my library. And so I'm going to connect this line here. I'm just going to draw it straight here. And then it says L is somewhere along the fire station, F is somewhere along the way at the coordinate 9, 25. So this is 25, right? And this is F, the fire station. So notice here, each of our coordinates is vertically in 5s. 5, right? This can be cut into 5s, 5, 10, 15, 20, 25. And it looks like if I started at the post office, what is the ratio P to F and L to F? So I don't know about you, but I think it looks like 2 bunny hops with 3 equal bunny hops left to go. Because when I cut this triangle, it's cut into 5 equal pieces, and this traces over to 2/5. 2/5 of the way there, but I don't want to pick 2/5 because they asked me not to list it as a fraction, but as one of these ratios. Nice work, guys. Check out the next video.